Okay, so hello guys, in this video I would like to discuss about the ionic bond. As you've learned before from your previous lesson that in IGCSE that you will only need to study the first 20 elements. So from hydrogen to calcium to 20, so the atomic number will be 20. That's the last thing that you'll ever do. And we've learned about the electronic configuration. So the bigger number actually represents the mass number, while the smaller number represents the amount of proton, electron. So they are both these numbers, while this one is the nucleon number. Okay, so in a way, today we're going to learn about ions and ionic bond. Let's take an element, for example, like oxygen. So it has 8 as the atomic number. So based on the electronic configuration, oxygen 8 would means that the first shell would be 2, because the first shell can be only occupied by a maximum of 2 electrons, while the second shell can be filled by the remaining ones. So 8, you already put 2 here, so the remaining ones are 6. So the configuration of oxygen are 2, 6. And this is called the electron configuration. So it means that the thing that we arrange here are the electrons. But what about the protons? So the protons remains in the nucleus. So by the hardware. So let's say that this is an atomic structure, this is the proton and this is the neutron. Then there would be some orbits, some shells. Then the 2 would be here and the 6 would be here. 3, 5, 6, something like this. So in the middle there would be proton and neutron, as we've learned in the atomic structure. But then we've had what is called by the noble gas. So it's group 8, the Roman number 8, or some people would also say that this is group 18, because they count all the way, all the rows from the first row to the last row. It's 18. But some of the most important ones we put Roman numbers. So group 1, group 2, 3, 4, 5, 6, 7, 8. So this would be most of the thing that we learn. So if you see like group 17, it means that it's group 7, or group 8, it means that it's group 18. It's the same thing. Okay. In noble gas, they're called noble because they have filled electron shells. Yeah. For example, like here, neon 10 and argon 18. So let me draw, yeah. So argon 18, neon 10. So for 18, the configuration would be 2. Yeah, the first shell will always be 2. Then we have 16 more. So 8. And then we have 8 more. So 8. So it's already full on the outside because 8 is the maximum number of electrons that can be filled in one shell. While for neon, it's also 2 for the first shell, and then the remaining is also 8. So see that in noble gas, all of the outer shells are filled with 2 electrons. So they're completely full. So it means that they are very stable in our environment. What about helium? So helium only has 2 atomic number. So it means that it only fills the first shell. But even if it only fills the first shell, then the first shell itself is already full also. So the goal for everyone, actually, that all atoms would like to be noble. Now, they try to achieve its nobility by getting or taking away or giving away electron. So let's see for oxygen. So for oxygen, there are 2 and 6. So in order for the outer shell to be noble, to be full, then we can do 2 different things. So the first option, we can either take 2 electrons here. And the second option, we can throw away 6 electrons, so that's as if that it is full. So as if that the outermost electron is 2 and the maximum number of electron that can be filled in the first shell is 2, right? So by doing this, oxygen can trick others thinking that, oh, it's full. So 2 options. either taking in 2 or throwing away 6. In this case, we would be able to assume that, of course, taking 2 is better than throwing away 6. So that's what oxygen will do. Oxygen will need to take 2 extra electrons so that it will have in total 10 electrons. From where do we get these 2 electrons? Can be from environment. But the source, it does not matter at this point. But the point is, in order to become noble, in order to become full, oxygen would require taking in 2 electrons. What about the number of proton and neutron? So if we see here, 8, 16. So the number of proton would remain 8. Because protons are located in the nucleus, so it cannot really move. The one that can move are actually electrons. Then what about the neutron? So here the neutron is the mass number minus the atomic number. So the neutron would be 8. So also 8 neutrons. In the atomic structure, we learned that 1 electron will give a charge of -1 charge, while 1 proton will give a +1 charge. So it means that 10 electron will give -10 charge, while 8 proton will give +8 charge. 8 neutrons will give 0 charge because neutron gives 0 charge. So it still gives 0 charge. Therefore, in total, now the oxygen, if it receives 2 electrons, we will have -2 charge. This is why oxygen will form oxygen 2 minus charge, ion, 2 minus ion, by taking in 2 electrons. Let's give another example. For example, like from the table, we can check, magnesium or sodium. Sodium 11 and 23. So let's write that down. So we have sodium 23, 11. So it means that it has 11 electrons and 11 proton at the beginning. So initially, as an atom, it has -11 charge and +11 charge. So in total, it will be 0 charge. Atom, usually, they are neutral. So that's why they have the same amount of electron and proton. It's because of this. But for example, that sodium would like to be ion. Sodium would like to be ion. So let's draw the electron configuration of 11. So 2, and then we have 9 remaining. We have 8, and we have 1 left. So in order to become noble, there are 2 options. Either giving away 1 electron or taking in 7 electron. I would say that giving away 1 is much easier compared to taking 7 from some other source. So in this case, sodium will form this configuration as an ion. So it will have 10 electrons in the process. What about the proton? The proton will remain the same as the original one. It will have 11 proton. So in general, -10 charge and +11 charge will yield +1 charge. So that is why we have sodium will create sodium +1 ions. So ionic bonds are bonds that are made by bonds from oppositely charged ions. So ionic bonds, one atom must contribute to the electron while the other atom will take in the electron. So let's say we have sodium and Cl. So Cl is actually 17. Sodium is 11. Let's draw the electronic configuration of sodium and chloride. But actually what's the most important is just the electron valence, or the number of electrons on the outermost shell. So 11 281 and Cl 287. We can draw as such that sodium 1 here and Cl, it's not representative, must be smaller, Cl 7, 1 1 2 3 4, okay, something like this. Because sodium, to create ion, would like to release 1 electron, and chloride, in order to become ion 287, it has 2 options, right? Taking in 1 or throwing away 7. In this case, it's easier for Cl to take 1. So how will they do it? The sodium will contribute the electron to Cl, so it will give it away. So how can we draw this properly? We can draw this by representing Na as a positive ion, because sodium will give 1 electron, so it will be positive 1. And Cl we need to draw, so 1, we draw 7 electrons, and we draw 1 more here. It's Cl here and Cl minus. So this is how we draw the sodium chloride. So 7 of Cl own electron and 1 from sodium. What about other things? How can we easily determine the ions that are formed from these atoms? Well, I have an easy trick for you. Usually, group 1 will create +1 ion. Group 2 will create +2 ion. Group 3 will create +3 ion. Typically, it's like that. Group 6 will create -2. Group 7 will create -1. Oh no, group 5 also, yeah. So I need to lower this. Group 5, -3. Typically, it's like this. What about group 4? Yeah, it can be both actually. Taking in 4 or throwing away 4. While for group 8, it does not need to do any kind of these steps because it's already stable. Therefore, for example, if we have magnesium and fluoride, and your teacher asks to draw an ionic configuration of this. So the first thing, of course, we need to determine the charge. So magnesium, if you see from the periodic table, it's actually group 2. Therefore, it will form magnesium 2+. While fluoride, actually it's from group 7. So it will form fluoride -1 charge. Fluoride -1 ion and magnesium +2 ion. So if they combine together, of course, it will not be 1 and 1 like sodium and chloride. Why? Because magnesium wants to give away 2 electrons, while fluorine only wants to receive 1. So you cannot force F to receive 2 electrons, and you cannot force Mg to only give 1. They both have to give or take exactly as the charge. So what will happen? Yeah, then magnesium will find another fluorine. Magnesium will find other F who is willing to receive the extra electron. Therefore, it will be something like this. Magnesium in the middle and 2 Fs next to it. So magnesium will form +2 ion. It means that it will give away 2 electrons. While F is group 7. So we can draw 7 electrons here. 1, 2. 7 electrons on the outer shell. This is also 7 electrons. Because magnesium gives away 2, you can assign something like this. So magnesium actually gives away, so that F will have exactly 8 electrons and it appears full. Yeah, so F will be in -1 and -1, something like this. So this will be the electronic configuration. Is there an easy way or an easy trick to do this? Yes. So for example, like you have magnesium +2 and F -1. If you just want to know what kind of molecule they will form, you can do cross multiplication. So just take the number, put it here, just take the number, put it here. So you will have MgF2. So this is exactly what you need to draw. One magnesium atom surrounded by 2 F atoms, and the magnesium will give the electrons to the F. So ionic bond, because they are oppositely charged ions, mostly the one that gives electron are the metals, usually it's the metals. And the one that receives are non-metals. So what about their property? Yeah, if they are diluted, they can conduct electricity. And typically, they do have high melting point. So we know that, for example, sodium chloride is an ionic component. Because it is formed by 2 oppositely charged ions, which are sodium plus and Cl minus. Imagine that sodium chloride is something like this. Imagine. Now, of course, in 1 grain of salt, yeah, some grains of salt, of course, there will not only be 1 molecule of sodium chloride. There will be tons. So just for illustration, yeah, there can also be this one, there can also be this one, also next to it as well, yeah, and all of them are connected, yeah, connected. They have like some kind of a bond, yeah, maybe something like this, and then maybe also on top of them, yeah. So this is the first layer, maybe. Then also the second layer, something like this. This is the second layer. So it can be 3-dimensional. This is the second layer. And the second layer will also connect to the first layer. Will create like a box. It stacks. And then it also expands. So this is what we call giant ionic structure. So they're like lattices of ionic compound. So if they're like this, then it's very tough to break them. And typically, because of this tight arrangement, they are usually exist as solids. However, if you dilute them in water, then usually water will be able to break these bonds, yeah, and free the ions. But that's for the other thing. That's why as solids, there will be no free movement of ions. Because no free movement of ions, as solid, it will not conduct electricity. But once you put this in water and the water will be able to break these bonds, then it would be able to conduct electricity. So this is about ionic bond and also giant ionic structure.